So I think we had done prior to this one. Now the question is the correct order of electron gain enthalpy with the negative sign of fluorine, chlorine, bromine, and iodine having atomic numbers these respectively is. So you need to tell me which concept you will apply and why. Your answer should have the reason also. Electron gain enthalpy we are talking about. Yes, the correct answer. Tell me the reason also why that answer is there. Hmm, fine. Correct. Ariman, yes, correct answer. Tell me the reason also. I want reason.
Sir, I've told the reason.
Hmm. But yes. Tanu, yes, that is electronegativity concept, but that is not as related to electron gain enthalpy. Here we are talking about electron gain enthalpy. Samad, no. Devyansh, no. Keep answering. Remember, if the answer is wrong here, hardly matters. But if answer is wrong in exam, it will cost you marks. Yes, Ariman, the reason is correct. Okay. So normally it looks like that fluorine should have the maximum electron gain enthalpy, but there is exception. Piyush is correct. Fluorine rather has maximum electron gain enthalpy, and the reason is in fluorine there is higher interelectronic repulsion after the atom gains the electron. So once the atom has gained the electrons, after that there is, so this is fluorine. The electron here, the size is very small. So the electrons which are already there, these actually repel this electron in fluorine. So that's why the problem there. So fluorine is not very stable after gaining one electron. Fluoride ion actually is not stable. So that's why this exception is there. Fluorine becomes most stable after losing the electron, not fluorine. It is B. Next. The correct order of ionization energy of carbon, nitrogen, oxygen, and fluorine is, when it is written ionization energy means first ionization energy. And we have done it. Similar question. uh, yes, Vedi, think again. Some correct, Samat correct, sub correct, Roman correct. So yes, that's why I am saying which one should be the correct answer. Arna Kavish. C will be correct answer because nitrogen will be after oxygen. So exception you have got correct, but due to exception, this will be the correct answer, not B.
Sir,
Correct. Yes.
sir, can you please once explain why the electron gain enthalpy of beryllium is more than boron?
Okay. Electron gain enthalpy, or you are talking about ionization enthalpy?
Sir, actually, last class I had a bit of confusion regarding this topic when I was revising, so I'm not sure if it was the ionization or
It
electron
was
gain. There
ionization
was some,
enthalpy. It
yes,
is
sir, there was
ionization.
some confusion regarding this.
Lithium, beryllium, and boron. 3, 4, 5. The configuration here is 1s2, 2s2. Boron is 1s2, 2s2, 2p1. So normally, if we move from left to right, ionization enthalpy increases. Okay, normally, but beryllium and boron, between these two, there is exception because from boron, it is easier to remove the electron because after losing one electron, it becomes more stable. Okay, fully filled subshell. Okay, 1s2, 2s2. Okay, 1s2 is fully filled. However, here orbital is fully filled. But this one is already stable. So first reason is this one. Second reason is the s orbital is very small as compared to p orbital. So if this is the atom, this is the nucleus, s orbital will be something like this, and 2s and 2p I am talking about. So 2s orbital is much closer to nucleus. So 2s electrons, these electrons are very close to nucleus. However, 2p electrons are not close to nucleus. Sometimes they may be far away from the nucleus towards the boundary. So it is easier to remove this electron from boron. So that's why ionization enthalpy is low. Is that clear?
Yes, sir.
So here, due to exception in this case, otherwise it would have been carbon, nitrogen, oxygen, fluorine because ionization enthalpy increases across the period. Across the period means left to right. But this is the exception. Nitrogen is stable due to half-filled configuration. So nitrogen's ionization enthalpy is greater than oxygen. Next one. The correct order of electronegativities of nitrogen, oxygen, fluorine, and phosphorus is. For that, you can use this diagram. This is how these are placed. Nitrogen, oxygen, fluorine, phosphorus. These are placed. So you need to tell me what is the order. Remember, it is decreasing order written here. Okay. Electronegativity. Okay. Subway perform yes, maybe yes, correct. Arna correct. Left correct. Summer think again. Amir correct. Karthik correct. Okay. And this is a straightforward, very easy one because you know that electronegativity increases across the period. It means it is written in decreasing order. All these are written in decreasing order. In decreasing order, it will be from right to left, decreasing. And again, electronegativity decreases down the group. So it means after here, it will move downward. It will be F, O, N. After that, it will move downward P. So this is a straightforward question. There is no exception at all. I will schedule a Viva, next week. So be prepared for all these questions. Or maybe towards the next weekend, because at the moment the UPs are going on. Next question. The polarizing power of the following anions follow the order. Now, polarizing power, there is some rule you need to remember. Okay. Yes, Bedi, tell me the reason also. Why? What is the reason for this answer? Yes. The reason is correct. Okay. Good. The answer here is D, and the reason is the charge density. Okay. Now, for understanding polarizing and polarizability, just understand there are two terms regarding this. The one term is polarizing power, and the other one is polarizability. Polarizing power means how much powerful it is to polarize the other element, the other atom. Polarizability is that how much an atom can get polarized. So suppose I am talking about polarizability. If I say there is one atom, and what can happen that the nucleus can move to one side. So nucleus moved to one side. It can happen due to various reasons we will be talking about. Then what will happen that because the positive charge is on one side, it will acquire partial positive charge on right hand side. And because now most of the electrons are on the left hand side here, so that's why this portion will acquire some negative charge. So here partial negative charge on left hand side. It means it has some polarizability. It got polarized. Okay. How much it can get polarized, that is called its polarizability. Whether it is polarizability is high or polarizability is low. Now, this can be polarized by some other molecule also. So suppose you have a neutral atom, its nucleus is here and it is surrounded by electrons. And it comes in the vicinity of, say, HCl molecule. So HCl molecule, say this is part is H, this part is Cl. HCl molecule is polar molecule because hydrogen is electropositive, chlorine is electronegative. So this is already polarized. Chlorine is electronegative, hydrogen is electropositive. When it comes close to this neutral atom, this negative part of chlorine will pull the nucleus towards itself. So what will actually happen? This atom will get polarized. Its nucleus will move towards left because it will get attracted by negative charge. Negative partial charge on chlorine will attract the nucleus towards itself. And when nucleus moves towards left, there will be some partial charge on left hand side and partial negative charge on the right hand side. Means this got polarized. Got polarized. So it means this one we are talking about polarizability. This one has polarizing power. HCl has polarizing power and this neutral atom is polarizable. Now understand it with some example. The question is the polarizing power means which particular ion out of these can polarize the other one. It depends on its electron density. Okay. So the electron density, if you see in this case, in this case, in this case, in all cases, electrons are same. 7 plus 3, 10. 8 plus 2, 10. 9 plus 1, 10. Electrons are same. Okay. Then what is different that we are saying that polarizing power of N3 minus is maximum, O2 minus is less, and F minus is least. Okay. So Yash Bedi said on the basis of electron density. Yash, elaborate that. Your answer is correct, but how it is related to electron density? Elaborate that. Unmute your mic. How? Is your mic working, Yash Bedi?
Yes, sir. Yes, sir.
Others keep thinking. Why N3 minus? These are isoelectronic species. Yn3 minus has maximum, F minus has minimum.
Sir, I think because the polarizing power also depends on the size.
It depends, yes, it depends. And
So,
size and density are related
so
basically.
sir, as like fluorine has the smallest size, so like it will have the like the uh,
What is,
So has it got something to do with the valence electrons?
yes, it has. That is actually the dominating reason in this
Sir,
case.
actually I found the electronic configuration. It was 5, 6, and 7 in respective cases. So I thought it might be inversely related to it.
No, it is not inversely. It is actually related to what charges are there.
Yes.
So basically, in this case, the density is not that much different. It is different, but what is causing the answer here, sorry. The answer is just due to this thing. If there is -3 charge, it will attract the nucleus of the other one with greater power. Okay. If this is minus charge, it will attract the nucleus of the other atom with greater power. So if I say that this is the atom and this is its nucleus, and I have N3 minus here. This is in ionic form actually, and it has -3 charge. It will attract this positive part with greater force. That's why this atom will get polarized maximum due to N3 minus. So in isoelectronic species, the rule is very simple. In isoelectronic species, greater the charge, greater the polarizing power.
Sir,
Yes.
can you please explain polarizing power once again?
Polarizing power is that how much it can pull the nucleus towards itself or electrons towards itself,
Okay, sir.
so that the other atom becomes a dipole. A dipole, do you know what is dipole? In physics, you might have done that or not. Dipole is similar to electric dipole is similar to magnet. Magnet has two poles, that's why dipole. And an electric dipole also has two ends, one positively charged, the other one negatively charged. So it is analogous to magnet. In magnet, north and south poles. In electric dipole, positively charged and negatively charged end. That is called a dipole. The name comes from two poles, that's why dipole. If you have this atom will actually become a dipole because the positive nucleus will get pulled by N3 minus and electrons will move away. The left part will become slightly positive, the right part will become slightly negative. This arrangement is known as dipole. It has one positive, another negatively charged dipole.
Sir,
Yes.
sir, is this polarizing power directly proportional to the negative charge only for the isoelectronic species?
If you are talking in isoelectronic species, it is a straightforward rule. If the species are not isoelectronic, then the density will also come in picture.
Okay, sir.
Electron charge density. Okay. Next question. The correct order of negative electron gain enthalpy of the halogen atoms is. We have halogen atoms: fluorine, chlorine, bromine, iodine. And the answer you know. Still, you are taking that much time. Yes, Vedi, Kartike. Others, tell me the answer. We have discussed it 2, 3 times by now. In previous class, today's class, we have discussed quite a few times. Subway, no. Yash Bedi, yes, correct. Kavish, correct. Good. This is something we have done, you know. Here it is written differently, otherwise it is same question. Here it is written delta EG H, electron gain enthalpy. But it is same thing. Due to exception here, chlorine has greater negative electron gain enthalpy than fluorine. This is the correct answer. Next. The increasing order of the ionic radii of the given isoelectronic species is. And the rule is very simple. Previous question, yes, Devanshi, correct. Samad, your reason was correct. Tell me the reason also, okay? Pratham, Tanu, Pratyush, Kartikeya, Yash, Vedi. Tell me the reason also. I'm not saying whose answer is correct. All of you have given different answers. The rule is very simple for isoelectronic species. Increasing order is asked. Increasing order. Now I'm telling you who have given the correct answers. Many answers are according to decreasing order. So check your answers. Okay. Tanu, it is not across only, it is about isoelectronic species. Arna, Ariman, Savya, Kartike, Pratham, Yashpedi, all correct. Okay. The rule is very simple. The rule is, and probably similar rule I have written, for isoelectronic species, size is proportional to negative charge. Okay. For isoelectronic species, I think I have told you this in previous class. Size is proportional to negative charge. This rule you have to remember. Okay. So positive charge will have minimum. 2 plus positive charge will have minimum. 2 minus charge will have maximum. B is the correct answer. Write down these rules so that you can recall and apply. Next question. Which of the following sets of ions represents the collection of isoelectronic species? Means they should have same number of electrons. No, Ariman, no. Pratham, no. Yash, Vedi, correct. Kavish, correct. Savya, correct. Amir, correct. Laksh, correct. Ariman, yes. Pratyush, yes. First, if I'm writing so if just I write the atomic numbers, these are the atomic numbers. So here, after losing one electron, 18. After losing two electrons, 18. After losing three electrons, 18. After gaining one electron, 17 plus 1, 18. So C is the correct answer. Seventeen, 19, 20, 21. So that's why you should remember their placement, the placement of elements also. And someone asked that how many elements we need to memorize. I said that, except group 6 and 7, a few elements there, okay, only you can leave. Otherwise, all elements you need to memorize. Specifically for JE and NEET, you should. Next. Which of the following represents the correct order of increasing first ionization enthalpy? Don't be in hurry, just check your answer first. Okay. You can use this diagram for your answer. But you should already know the placement of calcium, barium, sulfur, selenium, and argon. Argon you don't need to consider. It is anyway in all options towards the right side. You just need to consider 4. You can do by exclusion also. You can strike off the ones which are not correct. का काविश सव्य आमिर यशवेदी प्रथम correct. Arna correct. Yes. And the reason is very simple. The reason is the ionization enthalpy, if we are talking about, ionization enthalpy decreases down the group. So if it decreases down the group, calcium and barium, okay? So barium will have less ionization enthalpy than calcium. It means this one not correct, this one not correct. Here barium is greater than calcium. Okay. Here also barium greater than calcium not correct. The only option remaining is D. Yes, Pratyush. Ionization enthalpy increases across the period and decreases down the group. Yeah. So that's how you will get the correct answer. So in many cases, you will strike off the wrong answers and you will get the correct answer. Next one. For one of the elements, various successive ionization enthalpies are given below. Okay. So for one element, various successive ionization enthalpy means to remove first electron, to remove then second electron, to remove third electron, like that. The element is Tell me the reason also. Yash, Ariman, tell me the reason. Why? Okay, Yash. Okay, yes, correct. Yes. Just think again. Okay, now correct. Just see the difference. First and second difference not too high. Second and third difference not too high. Third and fourth, the difference is too high from percentage wise from 2750 to 11,580. That gives you the answer. The answer lies here. Yes, Kartikeya, Kavish, Ariman, yes, the reason is correct.
Sir, I don't know the answer. Can you please explain?
Yes, I will explain. Okay. Now, the reason is for first, it requires some energy. Second, it requires energy, but there is not much difference in first, second, third. It means because after third, the energy required is much high. It means after losing third, it gains a stable state configuration. After losing third electron, it gains stable state configuration or noble gas configuration. That's why the energy required to remove the next electron is very high. The one which gains a stable state or noble gas configuration after losing 3 electrons is aluminum, 13. So this is 15, this is 12, this is 14, this is 13.
Okay,
Yeah. So after losing 3 electrons, this will be 12, which is not noble gas configuration. This will be 9, no, this will be 11, no, this will be 10, neon configuration. Aluminum is the answer. Very common question which appears in your exam, or the concept at least. The question might not be same, but you will get the idea from the point that where the difference is high. That will give you the answer. Next one. The electronegativities of carbon, nitrogen, silicon, and phosphorus are in the order of. You can use this diagram for the answer. Electronegativities, remember, we are talking about. Carbon, nitrogen, silicon, phosphorus. Okay. Raman, tell me the reason also. Electronegativity in increasing order. Think again, Tanu. Okay. Ariman, Yash, Arna, correct. Electronegativity increases across the period and decreases down the group. Decreases down the group means increases because these are given in increasing order. So write the trend in increasing order only. Okay. Now, if you add these two vectors, okay, these two vectors, the resultant vector will be like this. This gives you clear idea that silicon will have minimum and nitrogen will have maximum. If you draw the resultant vector, you get clear idea. Silicon minimum, nitrogen maximum, and which is only in case of A. Yes, Samad, correct explanation. But again, There is a possibility when you move from silicon to nitrogen, the possibility is that you can move like silicon to phosphorus, then carbon to nitrogen. One possibility like this. Another possibility is that you can move silicon to carbon, then phosphorus, and then nitrogen. Because in both cases, if you are talking about decreasing, okay, sorry, increasing, then here also the electronegativity will increase from silicon to phosphorus, and silicon to carbon also electronegativity will increase. No, Kavish, in this case, there is nothing to do with the more stable state configuration. Nitrogen will anyway be more electronegative than carbon. Yeah. So the
Okay,
point here
sir.
is that the possibility after silicon, from here we got that yes, silicon to nitrogen, the vector will tell you that silicon will be the least one, nitrogen the maximum. But after that, whether it will be after silicon, carbon, or phosphorus, because in both the directions, the electronegativity is increasing. Silicon to phosphorus, you are moving towards right, electronegativity increases. Silicon to carbon, you are moving upward. Upward also electronegativity increases. Okay? So the rule is very simple. Across the period, the change in electronegativity is not that high. It is low. The reason is because shell does not change. Shell is not changing. Shell remains same. So that's why silicon to phosphorus first, the electronegativity difference will be less. But silicon to carbon electronegativity difference will be more than silicon to phosphorus. The reason is because silicon to carbon, the shell is changing from third shell to second shell. So first it will go to phosphorus, phosphorus to carbon, carbon to nitrogen. If any confusion, you need to let me know. Yeah? Next question. What is the correct order of ionic or atomic radii in the following? Think about it and then tell me the answer. Don't jump into the answer. Okay, Pratham correct, Arman correct. Someone think again. Yes, Vedi correct. The rule you already know. Kavish, think again. The rule you already know. It is increasing order of radii. Karthikeya, yes. Amir, yes. Samad, yes. Correct. So the rule is very simple. The ionic or atomic radii of isoelectronic species is proportional to the negative charge. Higher the negative charge, higher will be the radius. But the condition is these need to be isoelectronic species, and these are all isoelectronic species. So if you are consider silicon 4 means 14 minus 4, 10. It has lost 5 electron, 15 minus 5, 10. Sulfur has lost 6 electrons, 16 minus 6, 10. 17 minus 7, 10. Okay. So it means it will be in increasing order if either positive charge is decreasing or negative charge is increasing. So when I say the size is proportional to the negative charge, it means negative charge should be increasing or positive charge should be decreasing. This is the only case where positive charge is decreasing. So these type of questions are very common. You need to be clear about the concept. The electronegativities of nitrogen, carbon, silicon, and phosphorus. This is something we have talked about So I'm expecting everyone to give me correct answer. You can use this diagram. Nitrogen, carbon, silicon, phosphorus. Electronegativities we are talking about. Okay, Amir, Samarth, Kavish,
So that was for previous answer.
previous, okay. Hmm. Yash, Vedi, think again. Kavish, Karthike, Amir, Aryaman, Lak, Samarth, correct. Okay.
Yes.
This is the same question basically we have done. I have just uh, kept it again with one more option, different, difficult to predict. That's it. Otherwise, this question and this question, same, exactly same. Yeah. Electronegativities vector will be like this: silicon to phosphorus, phosphorus to carbon, carbon to nitrogen. Same thing. Next question. The electronic configuration of an element with maximum negative electron gain enthalpy is. Don't jump into the answer. Understand the question first. What actually it means when it says maximum negative electron gain enthalpy. There are two possibilities, but still, give me the reason with your answer. Okay, whatever answer you give me the reason. Subway, no. uh, Anyway, that might be related, but tell me the answer first. Answer and your reason should be in one answer. Okay, just in one answer, give me the option, correct option, and your reason. So now, even if you don't know the answer, you can tell the correct answer. Okay. Those who have given answer C, correct. Your reasons are also correct. But why I am saying that, and think in that direction in exam also, think in that direction what I am going to tell you. The question says the electronic configuration of an element with maximum negative electron gain enthalpy. In the periodic table, you know that maximum negative electron gain enthalpy is of chlorine. So if chlorine's configuration is there, that will be the answer. And this is the case here. C is the configuration of 17 electrons and it is chlorine. Having said that, okay. Now think all the options. Suppose we consider all the options. It gains one electron. So if after gaining one electron, it attains very stable state configuration, then it will lose a lot of energy. And that is the case of with chlorine, because chlorine after gaining one electron attains argon's configuration 18 from 17 to 18. That's why, because it becomes very stable, it loses a lot of energy. That's why maximum negative gain enthalpy. But there are other configurations also. For example, this one, if this gains one electron, it will attain 1s2, 2s2, 2p6. And that is fully filled configuration. That is neon configuration. This is also neon configuration it will attain. So why this is not the answer? Okay. And this one, When it gains one electron, it becomes 3s2. And 3s2, so s2 is again fully filled here. So we can consider this one also. But this is a straightforward rejected because it does not attain noble gas configuration. It's still 3p, okay, 3d are empty. So see, this E part is rejected. Now we have two options, this one and this one. These two attain noble gas configuration after gaining one electron. So it means they will release a lot of energy. Then why only C? The reason is when electron gets into smaller atom, remember the valence shell is 2 here in this case. Valence shell is 2. So when electron gets into this configuration, there is higher inter-electronic repulsion. It is more or less similar to what we discussed in case of fluorine. Okay, it is actually fluorine if you see. Okay, so fluorine when gains one electron has higher inter-electronic repulsion. So that's why, due to very small size of fluorine, it does not lose as much energy as theoretically expected. So that's why chlorine is the one which loses more energy because there is no such inter-electronic repulsion after gaining the electron. That's why C is the answer, not B.
Sir,
Yes.
excuse me, sir.
Yes.
Sir, can we justify the answer C on the basis of the placement that it has in the periodic table? Like for the P block, it is number 5. So the element would be, I mean, the group would be, sir, 8 or 9, somewhere around that. And sir, according to that, can we say so?
No, both are in group 17. Both these configuration are in group 17. This is fluorine configuration, this is chlorine configuration.
Yes, sir.
So exception is very much same what we have talked about earlier. Okay. That fluorine after gaining one electron has higher inter-electronic repulsion due to its very small size. That's why it does not lose. It is not much stable and does not lose energy as expected.
Yes, sir.
Chlorine loses a lot of energy. Next one. In the graph below, the one which represents an alkali metal with the higher atomic number is. See the graph, and this is atomic number on the x-axis and first ionization enthalpy on the y-axis. This question is very easy. It is just that whether you can apply the knowledge or not. Okay, Yash Bedi, correct answer. Kavish, correct answer. Devyansh, correct answer. Just see higher atomic number and alkali metal. What is the condition of alkali metal? Arna, correct answer. Savya, correct answer. Samad, think again. Alkali metals have very low ionization enthalpy. You know that. Group 1 elements have lowest ionization enthalpy. So you need to find that element which has lowest ionization enthalpy with the condition that it should have higher atomic number. Atomic number should be high. Okay. Samad, Karthikeya now correct. Good. Karthikeya is correct. Samad now correct. Pratham correct. So the higher atomic number M, and also M has very
Sir, is
low.
my answer correct?
Yes, E is correct M. Okay. Arnav Devanshi, correct. And it requires very low amount of energy, this much ionization enthalpy, and atomic number is very high. M is the answer. So just simple concept you applied that alkali metals have very low ionization enthalpy. Next one. An element belongs to group 15 and third period of the periodic table. Its electronic configuration will be. Now these type of questions are actually so easy and these actually appear in your exam. Okay. Yashvedi, Sab, Kavish, Kartike, correct answers. Laksh, Ariman, Pratham, correct. Okay. So basically, this question is why it is so easy because the only one which has 15 electron, okay, group 15, sorry.
Yes, sir.
Okay.
C part.
So yes, third group, if you say group 15, third period, okay. So you can easily find out how many electrons will be there. Third period, okay, 15 electrons will be there. How will you find that? Because third period last element is argon, 18th. Okay, 18th is argon. It means 15th will be 15 atomic number. Just try to understand what I am saying. You have first, second, third periods. In first, you have only two elements, okay? Hydrogen, helium. In second, you have lithium, beryllium, and then up to neon. In third, you have from sodium 11 till 18 argon. So if 18th group has atomic number 18, 15th group will have atomic number 15 here. That is how you will find the answer. It is easier here. But suppose the question would have been the 15th group second period, then you will say that the last one has 10, 18th group atomic number is 10, neon. Then 15th group you will say 17th, 16th, 15th, okay, 9, 8, 7, which is nitrogen. So this is how you will find the atomic number. So 15 group is given. Remember, it is not 15 atomic number. By chance, in this case, group number and atomic number same. But depending on the period, group 15 elements will have different atomic numbers. The moment you got 15 atomic number, this is the answer. Next, an element X belongs to fourth period and 15th group of the periodic table. Which of the following statements is true? Read all the statements and then tell me the answer. Fourth period and 15th group. Potassium, starting point potassium, end point krypton, 36, ending point 36. Okay, Yash Vedi, your answer is correct. Tell me the reason also. Samad, no. Arman, yes. Tell me the reason also. Yes. Kavish, Pratyush, Pranav, all correct. Okay. So if you are talking about 15th group is again nitrogen family, same Same nitrogen, phosphorus, arsenic, bismuth. Okay. Antimony, bismuth. Okay. Nitrogen, phosphorus, arsenic, antimony, bismuth. So because it is group 15 element, there will be half-filled nitrogen family, half-filled p orbital. Nitrogen has 7, 1s2, 2s2, 2p3. Phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p3. Okay. After that, when it goes to fourth fourth period, it means third period's d orbital will be fully filled. And if I talk about the group, so it is second group, nitrogen is in second, third, fourth. It means we are talking about arsenic after phosphorus. So if we are talking about arsenic fourth, it means 3d will be fully filled. So that's what it is written, completely filled s and d orbitals. And moreover, I want to show you just one thing, if I can have that diagram, how you can get the answer very quickly. Look here. Okay. If you see here in this diagram, you have phosphorus, okay, and above that was nitrogen. But when you move from S to P, here D block does not come into picture. Similarly, from magnesium, 12 to 13 here, and then phosphorus, D block is not in the picture. So that's why d orbital is not there, it is not filled. But if you move to arsenic, and if you move now from S to P, d block will be filled. This d block, these elements will be filled first, and then you will reach arsenic, which is the reference element here. We are talking about arsenic. So that's why the answer has this point. It has completely filled S and D. When we move to arsenic, before that, S, this S completely filled, and the D also completely filled. After that, P starts filling. This is how you will find the answer. Different ways to find the or get the same answer. But this is the easiest way to find such answers. Next question. Which one of the following has the lowest ionization enthalpy? This one is very easy. I'm expecting everyone to tell me the answer. Lowest ionization enthalpy, not maximum, lowest. Kavish, yes. It is slightly tricky, okay? Slightly tricky. Kavish, tell me the reason. Kavish, no, probably I think I will have to. Kavish, write your answer again because I think I, I had seen another answer. Hmm. So Yash Bedi, write your answer again. Okay. I will get quite a few wrong answers here. I am telling you. This one is easy, but still I will get quite a few wrong answers. Okay. Uh, well, those who are writing A and D, they should clearly see that A and D are fully filled and half filled configuration. A and D are fully filled and half filled configuration. So that's not possible. Okay. Now, why I said that I will get different answers, because you might get confused between B and C. Okay. And there is reason why you might get confused. The reason is B looks like that it is half filled. 3s1. It is half filled. So it looks like that it should require more energy. Okay. And this is 2p5. This is not fully filled or half filled. So you have to remove the electron from here. It should require less energy. So in that case, you might say that C will be the correct answer because this one is fully filled and this one is not fully filled. Or this one is half filled and this one is not half filled. So C can be the
Where is
answer.
my reason correct?
Uh, uh, just let me check. Yes, that is the reason. That is the reason.
Sir, I've also written the reason.
So can you check mine?
Yes, I'm checking. And you know, although most of the reasons are not telling me that thing, okay. The correct reason is you check the which metal it is configuration of, which element it is configuration of. So if you see this configuration, 11 electrons is of sodium. And sodium, alkali metal, will have lowest ionization enthalpy. It gains noble gas configuration after losing one electron. That is why this is the answer. And in most of the cases, just try to find out which metal this configuration is of. Instead of just talking about half filled, fully filled, always see the metal or the element, okay, specifically whose configuration we are talking about. Now, if you consider this one is configuration of fluorine. And fluorine certainly does not have low ionization enthalpy. It is towards the right side of the periodic table. Okay. So the concepts should be applied judiciously, cleverly, which element we are talking about. Okay. So correct explanation here is that this one after losing an electron will attain noble gas configuration, which will be very stable. That's why this is willing to lose one electron. So noble gas configuration is the key factor in this question.